So as I mentioned at the beginning, but in case we have a few folks joining later, my name is Emily Hughes. I work as a bioinformatics systems analyst at Harvard Medical School, specifically on the picture search platform on BDC. And so today I'll be talking about connecting genomic data files to phenotypic data. So before diving into the strategy or logistics on how to connect phenotypic data to genomic data files, I first wanted to introduce the two main tools on BDC that I'll be using today to demonstrate this. The first is the BDC Powered by Picture tool, and this platform empowers researchers to access data by facilitating approachable research for all skill levels. So it's essentially a search tool that enables data discovery and exploration, and researchers are able to search at the variable value and genomic variant level to understand what data exists. Researchers can then filter on those variables to apply inclusion or exclusion criteria to build a cohort. And once the criteria have been refined and the data selected, researchers can use Picture to export the data frame that's ready to go for research. This is all without opening any data files or mapping to any data dictionaries, so really streamlines and jumpstarts the research lifecycle. The second tool we'll be using today is the BDC Powered by 7Bridges platform. And 7Bridges provides a secure workspace environment to do data analysis and collaborate. And analyses can be set up completely using a rich graphical user interface or through scripting via API or application programming interface calls. It provides private cloud-based Jupyter Lab, RStudio, and SAS Studio environments. And cloud compute and cloud storage are available on AWS or Google. And there are hundreds of accessible and hosted pipelines to get you started. So now that we have a general understanding of the tools, let's dive into the plan on how we're going to connect the data. So our main goal with the demo today is to connect the phenotypic data from the NSRR Cleveland Family Study, or CFS. For right now, this is the only NSRR study I think that is fully ingested by Biodata Catalyst and available, but we are looking to ingest more as Dr. Redline had mentioned earlier with those circled studies on the figure. And so we'll be connecting this phenotypic or sleep data from the CFS NSRR study to the TopMed genomic data from the same study, the Cleveland Family Study. And so I've provided the PHS numbers or the dbGaP study accession numbers there if you're interested in looking more into these. And so to do this, we will first use the BDC Picture tool to search data, narrow down a cohort, and then add the variables that are needed to connect files. And I'll talk about this a little bit more later, but just to give you a general overview of where we're going here. So then once we've selected our cohort, we will export our data to the BDC 7Bridges platform using code through the Picture API. And then finally, we will use the BDC 7Bridges data browser tool to search and copy associated files over to our project. There are a few prerequisites to doing this process. So first, you must have authorization to access both studies or data sets that you wish to connect. So for example, if I wanted to link the phenotypic data from a parent study, call that study 1, to the genomic data of a TopMed study, so call that study 2, I must have authorization to access both study 1 and study 2. As a reminder, BDC uses the dbGaP authorization mechanism for data, so you will need to have a dbGaP data access request, an active data access request to get access through the BDC system. Additionally, to use the Picture platform, you must have an ERA Commons account. Just checking the chat briefly here.
Emily, in case you missed it, there is a question in chat that's within a nested chat set. So
okay.
You already partially answered the first question, which was, can you easily find any sleep data in BDC? So if there's anything else you want to add to that, and then there's the second part.
Can you easily find any sleep data in BDC? Yes, I believe so. So if you're interested in phenotypes specifically, we do have those available in picture, available for search. And then as far as the specific sleep files, so as Dr. Redline was mentioning, there are many different data types or data formats that NSR collects and makes available. And so that is ingested by BDC, and you should be able to find those files on either the Gen 3 or the 7 Bridges platform.
And the second part was what will make it easier to find and integrate sleep data in BDC?
I'm so glad you asked, and hopefully these next few slides cover it actually. So I'll go ahead and dive into that. All right, and it looks like Dr. Redline said TopMed has already harmonized a sleep duration phenotype, so that is also useful. Awesome. And so to accomplish this goal or this task, there are a few things we need to know when connecting data. And so the first is that the associated files often have some sort of identifier in the file name. And this is kind of the key, I like to think, to connecting these data files to the participants that you can get from picture. And so to understand what identifier is available in the genomic data, I used the BDC powered by Gen 3 tool actually to view a list of files. And so that is what this screenshot here is. And so you can see I've boxed in red in the list of genomic files, each file starts with a code NWD followed by 6 digits. And if you're familiar with TopMed data, you may recognize this as the TopMed sample ID. And so this is useful to know when creating your cohort and pictures, so we can be sure to export this information. And I'll be going into each of these steps a bit more in depth when I do the live demo as well. So another useful BDC tip for accomplishing this is that Picture has an add to export button. And so this means that instead of applying a filter on a variable, so that is this sort of action button here that looks like the filter icon, you can simply click the add to export button and it will add it as a variable to your growing data frame. And so this is helpful to use with the IDs that I mentioned on the last slide, and I'll be demonstrating this functionality later. So once we export the data, we are able to save the IDs that we have selected into a list using some simple code. As I mentioned, these IDs will be key to using in the tool later to find the data. And I did want to go over that the picture output formats participants per row and variables by column. So I've put sort of an example of this, just some fake data with variable 1 and variable 2 to give you an idea of what this picture output could look like. And then finally, the final tip or strategy that we're going to use to accomplish this is the data browser feature on 7 Bridges. And so this is an extremely handy tool that we will use to search our terms of interest, so using those IDs to locate associated files and copy them over into our project. And so once those files are available in our project, then you're good to get going on adding workflows and starting your analysis. You have all of your data in one place. So I will go ahead and hop into the live demo here. So let's see. I will go ahead and start with the picture platform. And so here I have logged into Picture, and to make sure that I have the correct data access permissions, I have logged in with my developer account. But as I mentioned earlier, you will need to use your ERA Commons credentials to access Picture. And so with my developer account, you can see I have access to all of the studies available in Picture, but these numbers will likely be different based on your personal authorization to access data. So I'm happy to talk more about some of the other features on Picture, but for right now, I'm going to focus on this authorized access. So authorized access allows you to search and query from all data sets that you have been authorized to access through dbGaP. And so here to start with a research example, after speaking with Dr. Redline, she had suggested that perhaps looking into apnea-hypopnea index would be interesting with age and sex. And so I did a quick search yesterday on what this meant. So, I'm glad there are sleep researchers on the call to correct me if I'm wrong. But from my understanding, the apnea and hypopnea index is the combined average apneas and hypopneas that occur per hour of sleep. And it looks like this is actually separated into 3 general categories: mild, moderate, and severe, where the mild is 5 to 15 events per hour, moderate is 15 to 30, and severe is greater than 30. So we will be using this as our phenotype of interest along with sex and age, and also get our cohort built so we can export to 7 bridges. So any sleep researchers on the call, feel free to chime in if I explained that incorrectly or if more details would be helpful. But I will go ahead and start. Let's say sex first as our first phenotype or term of interest. So when I search for sex, this is returning all of the variables that match the search term of sex across all studies that I'm authorized to access. So this could be in the variable name, the variable description, the variable values, the study name. Any part of the study that has a match for sex is returned as a search result. So you can see that there are over 300 variables that match, but I'm really interested in the NSRR data, right? So I can go over here to the filter search results by study tags and find the NSRR CFS study tag, which I think is right here. So you can see that this tag exists here, and I can click the plus sign. And now my search results are narrowed down, and I can see that all of the search results here are only from the NSRR CFS study. So this is useful to narrow down search results of common terms. So looking through here, I can see that participant sex seems like a good fit for my sex phenotype of interest. And so I will click on the filter button here in the actions column. So by clicking on that, I can see that this sex or participant sex variable is a categorical variable. So as expected, there are values for male and female. I can either check the box next to each or click the select all button up here in the corner. So if I click select all, both values are put over into the selected values column. So I'll select both, and when I click add filter to query, you can see that a few things have changed in the results panel over here. So first of all, my total number of participants has been updated to reflect my query criteria. So this means that there are 710 males and females in the NSRR CFS study. You can also see that this variable has been added to the added filters box down here. So this kind of gives you an idea of what you've added so far, how you've filtered down your cohort thus far. So next I can search for that. Oh, yes, I
May
think
I
I heard.
ask a question that are related to what you are doing right now? So what if I don't know the NSRR is the sleep? I want to search for any sleep related data. Can you do a search and find out which cohort that has sleep data?
Yeah, so I can do that at the end here. I'll go ahead and finish my the demo of this cohort specifically, and then I can go back and do that. Does that sound good?
Thanks. Yes.
Okay, awesome. Sounds good. All right, so just moving forward here, we will search for the apnea-hypopnea related variable. So this is the apnea-hypopnea index. And so as I was searching here, Dr. Redline provided some insight that perhaps this sort of variable could be of interest. So I can go ahead and again click the filter icon here. And so we can see that this looks a little bit different because this variable is continuous, right? So there aren't distinct categories, instead it is numeric. And so let's say I'm a researcher interested in moderate and severe apnea-hypopnea indices. So I can do greater than 15, and I will go ahead and leave the max blank, so that way the default will be the maximum that's in the data itself. So when I click add filter to query, again, we can see that my total number of participants has updated. So now there are 173 participants that have a apnea-hypopnea index greater than 15 and are male or female. And the final one that I'll do here is just an age variable. So if I search age, we can see that there are quite a few variables that are returned, right? So there are 390 variables that are returned for age. Now, let's say that I'm interested in age categories. So I can actually add, using the variable tags, the categorical variable tag here. So let me click the plus sign next to this. And so now there are 59 variables that match my search, but I still want to find participant age somewhere, right? So I can see that age diagnosed, I'm not necessarily interested in that. I just want the participant age in general. So going over here, I can see that another variable tag is the tag diagnosed. So let me actually exclude all variables that have the term diagnosed in it, because that's not really what I'm interested in right now. So by adding that, I can then take a look at my list here and see, okay, participants age category. That's exactly the variable that I'm interested in or that I'm looking for. So that's just to demonstrate how these tags can really help with your data discovery and data exploration.
So Emily, two things in chat. One's a comment from Dr. Redline and the other one's a question. Is it okay to pose those right now?
Sure, yeah.
Okay, so Dr. Redline said that if you see the long list from earlier, when you first did the search for age, that you can see that for sleep data, NSRR data sets may have very detailed information on variables, such as AHI, which may be defined multiple ways. So just supporting what you're doing.
Awesome.
And then we have a question from one of our participants today, or attendees. Can we use command, for example, our language, to repeat the all operations that you just did on screen just a little bit ago?
Yes, that's a great question. So yes, there are two ways to access Picture. One is through the user interface, which is what I'm showing right now, and the other is through code. So we have availability in both Python and R. So if you see any searches or any filters that I'm adding on screen today, there is an equivalent in either Python or R as well. So if you're more comfortable or more experienced with code, that is definitely an option.
For the access to the studies on BDC Picture, is it through dbGaP for authorized access?
Yep, so that's exactly right. Like I said earlier, the Biodata Catalyst system uses the dbGaP authorization mechanism to determine what researchers are authorized to access or not. So in order to apply for access, you will have to go through the dbGaP data access request process. So once you're approved from dbGaP, you'll be able to log into BDC, you'll be able to log into Picture, and you'll see the available studies pop up. Great questions.
You can keep going now. Thank you.
All right, so I will just quickly, add a few things here because I just noticed the time. So the last thing that we are interested in, so as I mentioned earlier, we do have the TopMed sample ID, and this is sort of the key. Sorry, this is finicky. This is sort of the key to linking the phenotypic data to the genomic data files. So if I go into Picture, I've cleared all of the tags, so I'm searching across everything now, and I search sample ID. This search usually takes a little bit because a lot of hits are returned, but right now I'm searching for the TopMed studies sample ID, and I'll be able to add this to export as an additional column in my data frame. So here you can see there are a lot of sample ID, over 29,000 variables that are returned. But if I scroll down here to the CFS study, so that's the 954. I can find the variables only for this. And so you can see that this is the CFS TopMed study, and I'm going to add to export this sample ID. And so by clicking this button, I add it to the export. And so then you'll be able to package the data using the Select and Package Data tool, and copy your token and your query ID and use the picture API then to export data to 7Bridges. So let me just quickly showcase the data browser tool in 7Bridges to kind of show you how this would work. All right, so I've created a project in 7Bridges, and this is what it looks like. And so I've actually already done the export with a new data studio. So this data studio is called NSRR Data Retrieval. And so you can see based on, I just saved this code that I created as a PDF so you could see, but you can see that I'm able to quickly connect to the picture instance. Don't worry about all of this output here. It's just saying, hey, you were able to connect. And then I paste my query ID that was generated in the Select and Package Data tool, and I'm able to export the data. So as each participant is a row and each variable is a column. And now what I can do is actually use the sample ID column to create the names of the files that I want to search for. So as I had mentioned earlier, if we go back here, we can see that the data name or the file, genomic file name is the sample ID followed by this text here. So I've essentially just created a list of those. And I saved that to this output here. So let me just copy all of these so I have them on my clipboard. And then to use the data browser tool, you simply go to the data browser, the data tab, and click data browser. And so here we want to search for CFS because that is the Cleveland family study is what we're interested in. And we want to search the TopMed files. So I will click the TopMed study and click explore. And again, I want the files associated with it. So I can click file. And then finally, I can click this search by ID button up here in the top right corner. And so here I'm able to paste all of the files that I've created based on that sample ID and click next. And you can see that there are 100 file hits that are returned, which is expected. And so if I search this, I can see that all of the files of interest, so all of the files based on the cohort I've built have been selected. And now I can copy files to project. So by clicking on this and selecting the project of interest, I can copy 100 files to my project here. So I have just copied things over. So let me go back to my project just to make sure. So by going to the Files tab, I can now see that all of my genomic files based on the cohort I've created in Picture are available here. And so now you're ready to get going on your workflows, on your analyses, and have it connected to the phenotypic data based on the sample ID.